Hello all, I've done some analysis on the hologram clip and I have new information to share. Here again are the equinoxes and the solstices. We have one coming up on the 20th. It's an important one. On this day, all things are equal. The planet is in balance, and on this planet this only happens 2 times a year. For us it will be March 20 and September 22 this year. The spring equinox is a bit more exciting as life will burst forth after this happens. I was just reading some ancient writings where people had written way back that they had witnessed predators and prey walking by one another and actually playing with each other in some cases on this day, and then the following day everything reverts back to the craziness of dog eat dog. Anyhow, let's move along. Okay, so I'm going to run the hologram clip here to refresh your memories. This is a very important clip, and I'm redoing it because I have new information, and I'm going to do some analysis that I never did. Here comes the wave at the bottom. There it started. The camera passes it. The wave was out of camera frame. That means something. Anyhow, here comes the second wave, and I'll get into this better. I'm just playing this once through so you can get a good look at it. I did manipulate brightness and contrast to bring out the wave a little better. Okay, in this image what I've done is if you look at the top, there's a red line that's angled and a blue line that's level. The blue line truly is level. It's perfectly level to the camera frame, and my scope was perfectly leveled when I shot this, as it is every time I use it. The red line, what I did is, since the hologram wave is so hard to see, I ran the red line up till it was about to go out of frame so I could see where the top edge hit, because when I freeze frame it, it's very difficult to see the wave. So the result is that the hologram wave is tilted 3.2, possibly 3.3 degrees to, I believe, the orbital plane. Now the reason this is important, and actually it's not the orbital plane, it's the lunar axial tilt. That's what's being measured with the red line, I'm pretty sure. The lunar axial tilt, when you look it up now, we are told that it's 6.687 degrees to the orbital plane. Strange thing about this is, when I look at older references, like a poster I have from the Apollo missions from the 60s, it says the axial tilt is 6.41. It's a little confusing. I didn't look into it. I don't know why there's a difference. The reason I think this matters is because if the lunar axial tilt is 6.6 and I just measured the wave at 3.2, it's almost exactly half. The wave angle is half the axial tilt. Now, I showed this for a couple reasons. People keep telling me, Crow, this is your camera. Well, two things I just showed you proves it can't be the camera. The tilt of this wave would be level if it was the camera. And in the beginning I showed you that the wave begins, the camera pans above the wave, and then the wave catches up. That's the second thing, and that is bulletproof. It is not the camera. Anyhow, I'm going to move on to the next slide. Okay, so in this slide, I wanted to show the bulge of the wave, and unfortunately when I freeze frame it, it's just too difficult to see. So what I did is I ran it up against that mare or mare, the sea, that big blob dead center. Just above the red line is, I think, mare, the Sea of Serenity or something like that, mare serenitium, whatever it is in Latin. At any rate, the blue line is the angle that you saw in the last slide of the wave. So in other words, the blue line represents the angle of the wave that was measured at 3.2 degrees axial tilt. The red line shows the bow. That's measuring the actual wave when I freeze frame it. Now on the edge of the lunar limb I can see a little bulge. It's easy to see on that side. It's very difficult to see in the middle and on the left side when I freeze it. Anyhow, this is a conservative trace I did here. It's actually a little more pronounced, and it does bulge. When I play it for you again, you will notice that the edges of the wave as they travel are not equal with the center of the wave until they get past midpoint and they begin to catch up at the top. So here's another reason why there's no way this is the camera. And before I get into the main new information that I found in this clip, I'm going to show you one more piece of information that shows the wave does not go all the way across the frame. It goes to the edges of the moon and that's it. So let me get that queued up. Okay, so in this clip I've added a ton of noise. I've manipulated channels and I've done some blending. Here comes the first wave. I've speeded it up to 200% to exaggerate the effect. Now the reason I'm doing this is because in a second here I'm going to mask the moon out. Now you're going to need to be able to see all the way to the edge of your frame. Here it comes. And look at that area. You will see no wave travel through that noise. There's better ways to do this, but the problem is it doesn't encode very well. So this is black and white, and it's going to encode the best I can do it. But basically, there is no wave past the moon. Okay, so I've given you basically bulletproof evidence that this is a filmed event. And by the way, I apologize for talking so quickly. When I do the voiceovers, sometimes it's difficult to fit in everything I want to say within the clip time. Anyhow, now it's time for the new evidence. And it's time for crow to eat some crow. Many people over time had pointed out that there's a UFO in this clip. And I kept telling everyone it was a bird shadow, which is what I thought it was until a couple days ago. 7 or 8 people in a row contacted me to say, hey, there's a UFO in this clip. And since I do not believe in coincidences, I went back and I started doing the analysis that you see here. So let me cue up this portion of the clip, and you will notice that when the first wave begins, a shadow on the left side flies by. And at this point, I think I may have been wrong. I think it's too coincidental to call this a bird shadow, and we'll look at that from a few different views. Okay, so while I was filming, I discovered even more new evidence. There's an energy wave that emanates from the bottom of the moon as the wave starts. If you look in the red circle here, I'm going to play it repetitively so you can see. It's difficult, so I'm going to change up the views, but in that red circle there's a lateral pulse going by. Here I change the view and I'm going to go forwards and backwards. There's forward, up there's backwards, forward, backwards, and forwards. Alright, I've manipulated the hell out of just about everything here to get a view of this, and I'm going to zoom in, and you can totally see that as the wave starts on the bottom, a kind of sideways pulse of energy goes across the lunar surface. I did this a bunch of ways because it's going to be difficult to encode this so that by the time YouTube gets done with it, it's still visible. Okay, now for the shadow. I have actually a little bit of evidence that shows this is a shadow on the moon, although I'm not 100%. You'll see the wave coming up here. This is about 30% speed, maybe it's 25% speed. On the left, it's going to come right out of where the wave meets the limb. There it goes. The circle's a little more jerky than the actual motion of the shadow. We're going to do quite a few repetitive views here, and then at the end, I'm going to circle it out and show you where it literally speeds up. Here it comes. I increase speed by 5% each time here. Now when the circle comes, watch that area. I timed when it goes over this, it's coming out of a mare or a sea, up a mountain face there, and it speeds up, and I can time this by frames. Watch again, and right there, zoom, right up and over and out in about half the time it took to cover the same distance prior. Anyhow, we're going to take one more look at this now that everyone knows what to look at. Watch the edges of the, there it goes. It goes out of frame and then comes back into frame. Watch the edges, the bulge in the middle, how the edges catch up at the top. Look at the tilt of these waves. They're not level to the frame. They're more oriented to the axial tilt of the moon. And here's the final view that I'm going to give you of this object. Actually, I should say event. I'm no longer going to debate whether this was my camera. I've given proof that this is a filmed event. It's probably technology. Anyone who wants to offer up what this might be, I'm all ears. I think it's probably a hologram, but if you have better ideas, that's cool. But I am seriously done debating if this is my camera. Cheers.